So now I'm going to solve another question. Find subarray with sum k. Given an unsorted array of integers, find a subarray which adds to a given number. If there are more than one subarrays with sum as a given number, print any of them. So this time, there could be negative numbers in the array. Okay, let me draw it out and analyze. Okay, so we can check this and then check. So we check every array starting from 10. If any of this subarray meets the sum k, then we can return index I and the end is j. And if not, then we can try the next starting point, which is 2. So we do again check. As we check, every time we get a sum of the subarray, we should compare it with k. And if they're equal, then we can return I and j. It means starting and ending point. Yeah, so this method, the time complexity is O of n squared, because we could run n times a loop of length n. So how can we make this more efficient? Okay, so we can try to solve it in O of n time. And that means we should loop through this array once or twice, maybe once. And as we loop it through, we should remember something which can help us find what we need later. So what should we remember? We should remember the sum so far. Let's call it current sum, because we need to find a subarray with a given sum. So the subarray sum really matters, so we can store that. Okay. Okay, let me draw. So let me draw another example. And so for example, we want this sum. So this is the sum we're looking for. So the sum is, we can call it k. So this is k, and k is now 2. So we need to find this subarray. And I put index here. So as we loop from the start, we can keep a record of the current sum. So let's see, current sum is 0, and then we add this first element to it. And then it's 12, and then it's 4, 14 -6. Just let me double check. Okay. Okay. So what we know is this, all the current sums and this k. So how are they related? Let me observe. So, oh yeah, so here 14 minus 12 is 2 equals our k, and 14 is a current sum of not here. If the current sum of this subarray and 2 is the current sum of this subarray, so that means if we use the current sum of this, we can find n minus k, then we get the current sum until here. So that means we can find the so the subarray with sum k may or may not exist. In this example, it does exist. So we can, if we imagine it exists, then we know that if it exists, then we can find a pre-sum, a pre-subarray. I mean, in front of our subarray with some k, with the sum of current sum minus k. With sum of current sum minus k. Right? Let me say it again. So we imagine the subarray with the sum k exists. So that means a pre-sum with a sum of current sum minus k also exists. So that just means we can find the 12. We can find it in our previous current sums that we have already stored in some place. So that means we need to perform a lookup to look up whether this exists in our current sums. So let's say check if current sum minus k exists in previously stored current sums. That means we should store all our current sums in a dictionary instead of an array for a better lookup time. Okay, so store current sums in dictionary. Okay, so if found in dictionary, then we know, we should store its index. So for example, here the 12th index is 1. We should store it as the value of the dictionary. So the dictionary's key is the current sum, and value is index. So if we found the key in the dictionary, we can know its index. And so we can find the beginning of our target subarray because it's just next to it. So we can return the index plus 1 as the start of our target sum subarray, and the end is the current index. As we loop through this array, we have a current index. Maybe I call it I. Okay, let's go now. The time complexity is all of n because we only loop once and store all of those in the dictionary, and then lookup time is all of 1. Yeah. So space complexity is all of n because we need a dictionary to store current sums. Okay, now let's write code in Python. What should I call it? Okay, nums. Just A is array, and K means our target sum. So we need a current sum, and we also need a loop. Do we need to loop until the end? Yes. So let me do a while loop. So I equals 0 while I is less than sub A, and current sum I haven't decided yet. Should it equal to 0 or the first element? So if it equals to 0 and we need to find a subarray whose sum is 0, then but it's okay because we're going to add it to add the first element to it. Current sum equals current sum plus a I if current sum equals k, we can return starting point is starting point is 0 and ending point is I. Well, current sum equals so if it's not equal to k, we should store it in a dictionary. I'm recording. So we should store the current sum in a dictionary. That means we should have a dictionary empty one, and the dictionary's key is current sum and value is I. And we also need to check if current sum now before we put it in the dictionary, we should check if current sum is not in dictionary. We put it in. If it's already in the dictionary, we don't need to do anything because we can output any subarray with some k. And now we can look up if current sum minus k in dictionary can return dictionary key is current sum minus k. So it gives us the index, and we need to add 1 to the index, and the ending index is our current index. Okay, so if we haven't returned nothing from, it can return -1. So I put this into a list, um, but it's optional. It's just my preference here. Okay, now let me check. Okay, yeah, it's a while loop, so I need to run I plus 1. Otherwise, it will be an infinite loop. Okay, it looks good to me. Okay, bye. Thanks for watching.